Alright, so you guys really can hear this, right? Because I've already test mic it, so it should be good. Alright, so I guess let's go then. So, hello everybody, and good early morning. So, yeah, how do I say here? Good early morning here, especially from Sarawak right now, because, yeah, especially from Sarawak, because it's a bit early in the morning, I can say, but in the morning, it's around 3, almost 3, yeah, around 3:31, 37 a.m. here in Sarawak. So yeah, in Sarawak, so it's pretty early morning here. So of course, a bit tiring here, but it's fine. I'm still okay. And yeah, looks like we are ready to go finally. So, and since Rocket Lab still didn't go anywhere there, so why not we review a bit of our launch day, of the launches day, right? And as you can see here, yeah, you can see here. So looks like it didn't change that much, huh? Alright. So that's you go. The thruster, all of the testing there and here and there. You can see. Alright. A bit introductory music to in the beginning here, and then stage separation, and then ignition will be second stage, and then you see there with the QE kick stage
We
here.
are just moments away from Electron's 74th mission, set to lift off from
Alright.
Rocket Lab Launch Complex 1 in
Sorry,
Mahia,
a little
New
bit
Zealand. The clock is at
distracted
18
there,
minutes to
but
lift
it's
off
still
for
good.
today's mission, our 60th launch
Alright,
of the
T
year.
minus
Hello and good
18
morning.
minutes,
My name is Sam
and
Peters, coming to
yeah,
you
T
from
minus
New
80
Zealand,
minutes
and
and 30
along with me
seconds,
is Jess
and
Hepworth,
looks like
and we'll be
we
taking
should
you
be
through
ready.
today's launch operations.
Thanks, Sam. That's right. It's an exciting morning over here at Mission Control.
Yeah, so you can see this is how
Hand-based
the names goes and whatnot here.
Pioneers of Space, or iQPS.
Yeah,
Launch preparations
so you can
underway
just see
all
there
morning at LC1,
what's
and everything
happening.
is looking green so far with
And
the
so
rocket, the
far,
weather,
why
and the
not
range.
we
We're
review
locked
a
in
little
and
bit
targeting the top of today's launch window,
what's
with
going to be
liftoff
the
set for 8:51 local time.
oh
or
yeah, so this is
7:51
how it looks like. The Electron rockets there standing pretty nicely here and there. Okay, and so let's try here.
Today's launch is our 6th satellite deployment for
Okay.
iQPS's constellation of Earth imaging synthetic aperture radar
Okay,
satellites.
so
We've been the primary
maybe
launch provider of
we'll
their
try.
constellation since they began launching their QPS satellites, and we've got another 6 missions to come for the constellation following this one. We've named today's launch
Alright.
the Nation Guard Navigates, as the satellite we're
Yeah,
sending
so
to
this
space
is how
is
it looks
called
like here.
Yachihoko-1 for the Japanese Guard of Nation Building. Today we're
Yeah,
heading to a
so
575
this is
kilometer
for the
circular Earth
for the
orbit
mission
at
one
a
here.
42-degree
This is 6
inclination
out
to
of 8
deploy
planned
Yachihoko-1,
launches of
where it
the
will join its fellow guards
for
in
most of the
space, all
QPS
already delivered
SAR
by
rocket
Electron. That
satellite
includes
series.
the Moon
Yeah,
Guard,
for this year.
the Lightning Guard, the Sea Guard,
So
the Mountain Guard, and in August, the Harvest Goddess.
yeah,
So
you can.
today, it's the
You have
Nation
already
Guard's
heard it.
time to fly.
Yeah, so this one is for the
With this being
Nation
our
God
6th
times,
mission for
like
iQPS,
it does
we
say
recently
here.
signed an additional agreement for a further 3 launches, totaling 12 launches for their Earth imaging constellation. Each
Alright.
dedicated launch, like the past 5,
So
is for a single synthetic
I'll
aperture
give
radar
a little bit
or
of
SAR satellite.
listen here.
We even provide the separation systems for these missions as well. They'll be deployed from a Rocket Lab motorized light band.
That's right. It's a privilege to be the primary launch provider for the iQPS constellation, and we're looking forward to many more. Let's hear now from
Alright,
the team
drone shot
directly
here.
about their mission and SAR constellation capabilities.
Founded in Fukuoka with the mission of establishing a space industry in Kyushu, iQPS marks its 20th anniversary in 2025. Today, together with more than 25 partner companies, mainly based in northern Kyushu, we are developing the world-class small SAR satellite, QPS SAR. SAR satellites use radio waves, enabling observation of the Earth's surface day or night in any weather. iQPS is steadily working toward a 36-satellite QPS SAR constellation, aiming for near real-time Earth observation almost anywhere on the globe. Since launching our first satellite in December 2019, we have continued to expand our fleet and gained extensive expertise in operations. In March 2025, our new R&D hub, QSIP, was established. QSIP integrates manufacturing, testing, and shipping on one floor, enabling production of up to 10 satellites per year. This boosts efficiency and development speed, accelerating launches
Yeah,
and service
should work.
readiness.
Yeah. So you can see they actually launch on pretty much various rockets there. Sometimes on board, like you see Atlas 5 rocket, sometimes with EPSLV1. Okay, but so far looking
Our
pretty good.
satellites are used for inspecting large infrastructure and monitoring wildfires, earthquakes, eruptions, and
So
other
that's basically how
disasters, helping detect crises
the
early.
purpose of this QPS satellite
As
there.
natural disasters and geopolitical risks increase worldwide, the need for our high-precision observation data grows more urgent every day. Faster, more accurate, covering more places than ever before. We will continue expanding our constellation, realizing a world where Earth is observed more frequently. Unlocking the potential of space and contributing to human progress. The challenge of iQPS continues.
Yeah, so that's basically it.
We've absolutely
A
loved
bit of
working
the
with
show there.
iQPS to
You
build
can
their constellation, and we really are honored they've
from
trusted
them,
us as
from
their
the
go-to launch
iQPS
provider.
team.
In fact, we've
You
actually
can
had more Electron
you can
missions for
actually see there.
iQPS this year than any other customer, and it's
All
been a
right.
beautiful partnership. Alright, so we've got a nice frosty
Yeah.
Electron
So
inside
I've
there.
already
The team is
zoomed a little bit
finalizing
there.
loading liquid oxygen, or LOX, into the vehicle.
And so far,
This
I
super
do have
cold,
my press kit
high-performance
here,
propellant is loaded onto Electron
just
as
for a little
close
bit,
to launch as
so we
possible,
can
as it's
mention
essential
here
to
and
keep
there.
it in its super chilled state.
And
The
for one
stage
thing for sure,
operator
you need
is
to know that
responsible for
for
fueling
this
LOX,
flight,
and their status will be confirmed
it will
next
be
during
headed
the
into the
go/no-go
575 kilometers
Today we have operators in mission control
of
here
the
in
sun
Auckland
synchronous
and at the
orbit
launch site
around
in range
around
control.
42
We
degrees of
actually have 5
inclination.
mission
Yeah, that's one
operation
thing for
centers
sure.
where we can operate both
And
launches and space operations.
yeah, the
And
customer
today's
you
launch
really already know.
director
It's
is Taylor
iQPS.
Moore, who is
iQPS actually
managing the
stands
mission
for
from the range. Taylor will pull each
Institute
of our
for
station operators from their
Q-Shoe.
readiness to
Yeah,
proceed
just
to
also
launch.
another
We're looking for a
word
go
player
from
for
each
Kyushu,
operator to
pioneers
confirm
of
that
space
Electron is ready for
incorporated.
flight. Let's check
iQPS.
in
That's
with the
one thing for
LD.
sure. So that one is, and of course this is an Earth imaging slash observation
Proceeding with
company.
the go, no-go sequence.
Okay,
Commencing with stage.
let's hear
Let's go.
the go
Avionics.
no go
Avionics,
point
go.
here.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
is go.
LD sub.
LD sub is go.
The go no go sequence is complete. We are T minus 11 minutes and 27 seconds and counting.
Alright, so everything is go.
At T minus 10 minutes. From this time, the 3-word procedure is in effect.
Alright, so around Mark T minus and 10 minutes, locks propellant by then should have already been ready
all systems, and the
for
nation god
most of
is
the
cleared for
rockets
flight.
itself.
We're now
So
at
that's one thing for sure.
11 minutes in the countdown, and so far the mission is continuing nominally. The payload
Yeah,
is
so
ready, and
good
the
thing
weather
this is
still looking
still
good for today's
go
mission.
for the
Our
launch
T0
itself.
launch target is set for 8:51
Alright,
a.m.
and looks like I can
While we wait for
continue
the
a little
LOX
bit
loading to be
here.
complete, now is a good time to share an update on another Rocket Lab mission that's about to launch.
Okay,
This time involving 2 of our spacecraft bound for Mars. The Escape and Plasma Acceleration and Dynamics Explorers
Okay.
mission, or ESCAPADE, will send our 2 spacecraft to Mars
okay,
to
okay,
study
okay.
the red
This
planet's
one.
unique hybrid atmosphere for NASA and UC Berkeley's Space Sciences Laboratory, helping scientists better understand the processes that drive space weather
This one is
changes
for the
there.
escapade missions.
That's right.
Huh.
The 2 spacecraft named Blue and Gold after Berkeley's school colors are in Florida and ready for launch from Cape Canaveral Space Force Station. The pair are based off our Explorer spacecraft platform.
So
Now, when they're in their stowed position, they each measure about
this one is the
1.5 meters
escapade,
wide,
but
or
for the
around 5 feet.
Blue and
But
Gold,
once
if
their
I
solar array is deployed, that
hear that
measurement extends
correctly.
up to 5 meters, or
Interesting.
around 16 feet wide. Each of them weigh just about 200 kilograms or 440 pounds, and they weigh more than double that once they are fully fueled for the mission.
After launch, the spacecraft will loiter in Earth's neighborhood for 12 months until the planetary alignment window opens for their 22-month journey ahead of them to Mars. It'll take 11 months to get there as part of the crew stage, and then the pair will have 11 months to conduct their primary science mission once they're at the red planet. The twins have been patiently waiting for their moment, and that time to launch to Mars is now closer than ever. Let's take a look at the journey the Escapade spacecraft and our team have taken these past couple of months.
Alright, so we are going to hear the
Escapade is
update
a
for this
low-cost
one.
dual spacecraft science mission to study Mars's hybrid magnetosphere. It's funded by NASA. Science is led by the University of California, Berkeley, and the spacecraft bus is provided by Rocket Lab. The bus is basically what takes the science instrument from Earth to Mars.
You see,
and it's what keeps the satellite alive.
that's actually looking pretty
The more we
good
learn about
for the
other planets in our solar
escapade
system, the more
itself.
we also learn about our
This
own
one will
planet
be
and its past and
bonded
maybe
to
its future
Mars.
as well.
Yeah, will
You
be
know, this
bound
mission
to
Escapade
Mars
and
there.
going to Mars is helping
Right.
us understand its magnetosphere. But not only that, with a platform like this, it can be adapted
So
to
looks like they are
many
going
different
to
missions, and each of those missions may have their own way of improving life.
they are going to do this
So
for a
Escapade
little bit.
represents basically doing science at a order of magnitude lower than previous. You know, we're doing it for, you know, less than 80 million for spacecraft and
Yeah,
launch,
look at
which
that
is
clean
huge.
room inside here.
made these spacecraft at the price point we did
Clean
was by
room,
developing
lots
them
of
over
things there.
about 3 years instead of the typical 10.
So today we brought our spacecraft in from the truck into our integration facility here, and we've been moving our spacecraft onto their rotation fixtures and setting up our ground support equipment for the rest of our testing campaign prior to launch. There's been a ton of work leading up to this. I've been working on this program for almost 2 years now. Definitely means a lot to be here and this close to launch.
I think the team is amazing.
Yeah,
There's been,
so
you know,
that's
few
that.
ups and
You
downs
can
along the
hear
way,
it.
and they just keep persevering. It's been a lot of hard work to get to this point, for sure.
I mean, the biggest challenge here is that part of the NASA Simplex mission is that we have to be compatible with a lot of different launch vehicles. So actually trying to design for 12 different vehicles and then eventually getting down selected to New Glenn was actually quite difficult to envelope all those performances of all the loads. So I got to design the spacecraft to be fairly robust, which is great because it's helping us get through on this rocket coming up.
Escapade really fits well into Rocket Lab's overall mission to be an end-to-end space company, and it's a beautiful example of what we can do when we bring everything in-house. The Escapade propellant tanks, for example, they were developed in record time in less than half a year.
Rocket Lab is an end-to-end company, so we're fully vertically integrated. We found a way to be able to parallelize the entire development and production of the spacecraft.
So looks like even for the thruster they are able to develop it less than develop and even test
Honestly,
it
feels like a
less
dream come
than
true to be working
than
on a
half a
real
year.
spacecraft.
That's
I'm
good.
touching hardware that I've had an impact
I
in
mean,
designing,
usually it can
building,
be
and
pretty
testing
long, but
that is going to another planet.
I think to see
but if you
for real
design it
for the first
properly,
time will just
why
be
not?
kind of pretty surreal to begin with.
And
We'll
this
probably all be gathered
and
here
before
for
the
the launch
escapade
and
mission letter, that
yeah, we'll just be
that
waiting for
one is
first
actually
contact. But I
bound
think
to
once we
Mars
get that, it'll be all systems go,
for
and from
mostly
here
to
we'll
do
just
a
be
little
from
bit
one
research
milestone to
of
another, and it's just going to be
not a
fun
little
to be
bit,
part of
a
that
lot of
journey.
research
My
about
dream is
the
that, you know,
Martian
projects also goes
surrounding
from billion-dollar government programs
ionosphere, some
something much more achievable that is within
ionosphere
the budget of the university.
heliophysics
Escapade takes
related
that
stuff
first step.
there.
What it unlocks
So
is
that's
additional
interesting.
deep space high delta V missions, things like Mars telecommunication orbiters, asteroid rendezvous, mission to Venus, or even further.
Alright, you can see there. Even the logos there
Escapade
looks
is such an
interesting.
important mission. The science
Okay.
that Blue and Gold will conduct could help researchers
I mean,
better understand
I do
not
wish
just
I
how
can
the atmosphere
comment a
and
little bit, but
magnetosphere evolve at
I
planets like
guess
Mars,
it's
but also
fine.
use that
Let's
science as a model to compare Earth's own
let
magnetosphere
me
and
see what I
atmospheric
can
state.
actually
We can't wait to see this
shows
mission
to
finally
you
fly
instead.
soon. We've got our fingers crossed, so keep an eye on our socials to follow
So
their
here
journey to
we
Mars
go.
once Escapade is launched.
Okay. Okay, they are waiting a little bit, right? Interesting.
LD GCL mission. GCLD.
Alright.
Down mechanisms are armed. Strong back is retracted for flight.
Copy GC.
Alright. So why not, yeah? Alright. And looks pretty interesting there. Why not? While I'm still waiting, right? Let's try go here. Okay. Yeah. So meanwhile, meanwhile we are still waiting. Why not? We can go and try here. Okay. So looks like it. Okay. Nice. Looking pretty good. So we're going to be back on the press kit here.
We are just 4 minutes away from our T0 liftoff target, right 51 a.m. local time
Alright,
here in New
still
Zealand.
okay.
We're tracking no
So
issues with the rocket,
here you can see
payload,
this
the
is
range, or the weather
this is the
as we
press kit
head
itself,
into the
but I'm
final
not going to
count.
show you too much.
Electron's flight
Okay,
computer will take
but
over the
you can see
countdown,
this is
and
why
we're
I've
in the
said
last 2 minutes or so of
it's
the pre-launch autonomous
targeting for the
operations.
575 kilometers. While it does say circular Earth orbit, it's mostly going to the sun synchronous orbit, aka most always facing this daytime, the sunlight daytime, so it's able to keep consistent with the observation, of course. And this one here, it will go for the 42 degrees inclination, and customer, you already know, it's iQPS, aka stands for Institute for Q-Shu, Pioneers of Space Incorporated, iQPS. Yeah, so you see Q-Shu, and also that one is pretty pun word for them, that one. So you can see this is the Nation God Navigate satellite here, and this one is one of the previous mission. It's pretty similar, and you can see there's a little bit like how do I say, like a retractable antenna there, which when unfurled it will be pretty big, of course, for this one. And this one also another how do I say? Alright, looks like pretty green there. Okay, this one you can see on the top there. It's also one of the important thing other than this antenna dish there. Also another antenna there to magnify across the camera itself. And you can see sometimes they like to keep it a little bit secretive, so that one is getting blurred. You don't see anything super duper important, but you can barely just see there is like a bit like antenna focus there, and then going to the camera. Yeah, all the sensors, delicate equipment here and there. And of course this one, they actually aim to deliver every 10 minutes of the high resolution Earth monitoring slash observation satellites there. Okay, looks like we are almost ready to go at T minus 1 minutes and 45 seconds. So looks like it. Oh, so looks like for this year it's going to be 6 out of 8 plane launch, but overall overall if this
Box load is complete. System is in recirculation.
alright, so looking good. So pretty much with 6 contractor missions left, which means possibly next year it's going to be 4 plane launches left for 2026. Yeah, in case you see this in the future, and looks pretty good. And you can see this satellite just only cost one per 100 of the traditional SAR, aka synthetic aperture radar satellite, and this one is just 1/20th of the weight. So yeah, I don't have too much time here. You can see it's the bridge.
Stage 1 and Stage 2 tanks suppressed for flight.
Alright, so this is the mission patch itself. What it does is composed of 5 stars of previous iQPS missions on Electron, yeah, compass and star, representing Yachihoko as the mission, as the nation building and navigational god, city line and 3 representing the nation of Japan and whatnot, yada yada. So yeah, because I cannot describe too much, and this is the launch profile.
T minus 20 seconds and counting.
Alright, so looks like here we are ready to go. Alright, so ready, we are going to launch. 10 minus 10,
8, 7,
6, 5, 4, 3, 2, okay, all 9 Rutherford rocket engine ignition, and liftoff from the Mahia spaceport, yeah, from the Mahia spaceport on the Launch Complex 1B, the Rocket Lab Launch Complex 1B. So we can see it's lifted off and looking pretty nice, looking pretty good. And this is the view, the beautiful and majestic view of the rocket onboard side there. And you can see, looking pretty nice there.
Electron has cleared the launch pad.
T plus 40 seconds, and at some point it's around T plus 55 or 56 seconds. It should be max Q, okay? Alright, max Q. Alright, supersonic Mach 1 already going to the sound barrier, and also max Q, maximum aerodynamic. Ready? Alright, so looks like max Q already clear the maximum aerodynamic pressure. Okay, it's already passing to the max Q, maximum aerodynamic pressure fully exerted on the launch vehicle itself. So usually before it goes to max Q around at some point of the flight, before it's even going to the Mach 1, usually the rocket engines itself will be throttled down to around 60% typically, just to ensure the launch vehicle itself didn't experience that huge amount of the aerodynamical stress there. So that's why. And after that, after it's going to the max Q, only then all of the rocket engine itself will be
15 seconds
throttled up back to 100%. Okay, so looks like getting ready for the stage separation. Okay, so getting ready. Okay, so this is how it looks like inside there. Okay. Alright, so you can hear the microphone there and stage separation, and we have ignition of the second stage. So you can hear it. The microphone on board of the rocket camera itself already pick up the sound there. Okay. So clean separation and
on the second stage has fired up to continue the mission to orbit.
Alright, so now continue on the mission, and I need to remind you, almost every almost every stages of this Electron rocket except the kick stage, aka the upper stage. Everything is almost everything is the Kerolox itself, which liquid oxygen as the oxidizer, and also super refined kerosene, RP1. Okay, so you can see this is the firing separation has already confirmed. Okay, firing separation has already confirmed. And looks like the mission is still good and still on still bound for the orbit, for the sun synchronous orbit there. Okay, so I stop around the Kerolox, okay, the liquid oxygen as the oxidizer, and super refined kerosene RP1, aka the rocket propellant one, but basically the super refined one usually has even lesser or almost no or really no lead inside any of the composition, because usually you can see it's pretty it can choke pretty fast off the rocket engine, and it also can be pretty corrosive if it does have the lead and element inside there. So usually that's why they are using the RP1 for the fuel. Super refined kerosene, of course, specific for the rockets and also for the aircraft usually. Okay, and you can see this is the in front of the view, and pretty good. And by at some point there should be a little bit like the slight barbecue roll there. Usually what they do with a little bit of rolling here and there for the rocket and also for the satellite itself is to ensure it has it didn't to ensure that most of the heat can be distributed much more evenly, especially because this is a little bit of because it's already heading for the alright, ready for the some battery jettison there, so it can ensure it can eliminate some of the dead weight causes by the discharge of the battery itself on the second stage there. And also just where do I stop there, and also it does a little bit of the barbecue roll there, just to ensure it has even cooling and also even heating there, just to ensure it's not going to heat up too much of the part of the rockets and also satellites, to ensure it's still okay and not damaging anything there. And getting ready for the battery jettison there. Get ready for the go. Alright, so pair of the battery jettison has already confirmed. Alright, hot swap successful, which means which means some little bit gap here and there, around few hundreds of milliseconds. It changes some batteries to another battery packs, and then it's just separated there, because you need to know that if I remember, even up until this to this day, if I'm looking at the situation, Electron rocket is the only successfully the most successful operational rocket that actually operates on the electric rocket engine, electric pump fed rocket engine there. Yeah, so in other words, from what I can say is that instead of the rocket engine itself using whatever turbo pump, a bit complicated stuff, they just replace it something with the if I remember, it's a motor rotor, something like that, and also battery. It's just connected in there. That's basically become a little bit of the replacement for the how do I say, replacement for the turbo pump. So they just replace that turbo pump with the a little bit of
Right, so
a
we're
small
coming up now
motor
on our
rotor
final
there
staging event
inside there,
before payload
attached
deployment. It's
attached with the
processed very
battery and
similar to
some
MECO, which we
computers here
completed
and
with the
there.
first stage
I mean, of
just
course,
a few
it's
minutes
very
ago, but
important.
this time we have
And
SECO for second
looks
engine
like the
cutoff,
velocity is
that vacuum Rutherford engine you see on your screen over
23,000
there.
kilometers per
We should
hour
see it
and
shut down
altitude
in
is
preparation for the second stage to release the
260.8
kick stage
kilometers.
and send the Nation
So
Guard on its
looks
way
like
to
it.
orbit.
And
Standing by
still
with mission control
going
now.
and ready. And here we go. And getting ready for the for some few tenths of seconds before the second stage rocket engines fully shut down, and then it will separate, and then by theory it should separate together and maybe.
Seco confirmed.
Alright, and looks like second engine cut off confirmed. Seco confirmed.
Great news,
And stage separation confirmed.
on the second stage,
And now
successful
the
deployment of
QV
the kick stage to its nominal transfer
QV,
orbit.
aka
Great
if I
news for the
remember,
mission
some
so
of it also
We're
using the
here in an
hyper
elliptical
QV
orbit for about 40 minutes or
kick
so
stage.
until we reach our planned apogee. And then
Now,
it's our Curie
now
engine's
basically
time
just
to shine.
together with
Curie
the
is our secret sauce to our extreme precision.
um,
About 4
that's
minutes
basically
before
attached
payload
together with the
deployment, our
satellite.
tiny Curie engine
And
will
right now
ignite
it's
for a 3-minute
going
burn
for the
to circularize our orbit ahead
going
of
for the
delivery for
cost
QPS SAR 14.
ballistic
That's
flight
right,
there,
but for now,
usually
we're gonna take
aka
a break
not
from
turning
the
up
broadcast
any
while the kick stage
turning
does
up
its
any
thing,
of the
and
rocket
we'll come
engines,
back and
no
join you to
throttle up.
listen in on
It's
those
just
final
stay
moments
like they're
before payload deployment.
a
See
little
you
bit
back here shortly.
for some leisure journey there until they're ready for the flight again. So why this some cost with ballistic flight is needed? Because of course you want to maximize the engines and also the saving for sure. You want to ensure that you can use that fuel sufficiently for, let's say, for whatever purposes you want to inject something to the orbit, going ahead away and whatnot. So that's why usually cost-based ballistic flights are pretty important here and there. And yeah, and usually it's also part of the, if I remember, part of the orbital mechanic effects, if I remember correctly. One of it, very important. Usually, after quite sometimes around desired orbit, aka let's just say like around the apogee. Apogee is basically a fancy word for the upper boundary of the orbit itself, the highest point of the orbit. Usually after it reaches almost apogee altitude, or around that apogee altitude, usually after that the thruster itself, the rocket engine itself, will ignite on the kick stage to finally circularize that satellite into the correct orbit position, and also some slot there, because at the end of the day it's really targeted for the 575 kilometers of circular sun-synchronous orbit, sun-synchronous orbit, that usually always facing to the daylight sun, to ensure constant consistency of the sunlight itself. When they actually decided they want to do some observing, okay, it can actually take the pictures of the literally almost the same day. So they are able to, of course, do a little bit of research here and there. So that's basically one of the important aspect of this flight itself. Okay, and while we are having nothing to do, so I've already opened up this music here and there. Okay, and this is a little bit boring, of course. I cannot just say anything super duper special here and there. Yeah. Okay, so that's why. And then after quite some time, it's already circularized into the correct orbital position, and also the yeah, orbital inclination position, and also the desired circular orbit, 575 kilometers of altitude, with, if I remember how is it? Yeah, if I remember, around 45 degrees should be. Oh no, 42 degrees orbital inclination, not much else. So why not? Okay, and after that, only then the GPS satellite here, number 14 in this case, the Yachihoko-1 satellites here, the nation, basically this one is named after the nation god itself, okay, the Japanese nation god. Okay, so here and there, after that the mission would be considered as successful. It's fully separated, and finally it would be slowly deployed one by one, even until the antenna boom, or how do I say, like the antenna shield pointy boom there, fully deployed. The circular one, it's opening up slowly and slowly in front, almost in front of it, just a second behind the most, how do I say, behind the most upper antenna holder there, here and there. So I don't know how to properly pronounce that, but that's my best effort here, there, and so far. And looks like for now it's still costing, but now this is a little bit like simulated pathway, but mostly pretty accurate there. And so until it actually until there's another ground station there, here and there, usually not much else we can see here. It's a bit boring, of course, and it's taken, it will be taking us almost around an hour plus there before we finally go. Yeah, I mean, the only time where the kick stage, the kick/upper stage of the Curie, or maybe Hyper Curie rocket engines ignite, it's going to take around up until T plus 46 minutes and 34 seconds. Yeah, it's a bit long and boring here, and I don't think I really can contribute that much at this point. So it's a little bit of the dead air here and there. So maybe why not, while we are waiting, maybe I can give a little bit more. Yeah, maybe I can try give a bit more overview about this mission here, while it's pretty calm, before I took a little bit of my time to just take a nap here and there, just before we finally go. So I guess, why not we try something important here. Alright. Okay, I'm going to give here, so I'm not going to bore you guys with nothing else to do. Okay, so this is what I meant. This is like, how do I say, the circular antenna shield, something like that. Yeah, it basically will work as it's basically working as the double, for the double purpose. Number one is to shield the camera, and also sensitive equipment from how do I say, overheating of the sun, and also from getting all of their sensor to be overwhelmed by the sunlight. So of course this antenna boom shield here, this circular one here, will protect that very, very delicate equipment here and there. And you can see this is the solar panel there. I mean, I bet that if you really bring this technology back into the 90s, maybe early 2000s, it's basically going to blow lots of mind here and there, or maybe even just like time travel, time sleep, whatever you want to call it. It's going to alter the course had we have this technology like 30 years ago, or maybe as early as 20 years ago. But yeah, pretty cool, right? Cool time. And you can see how many they've already deployed under the Rocket Labs rocket here, Electron rocket. The first one is the Suguwa-1, which was deployed in 2023, and Susanoo-1 deployed in March 2025, and then Wadatsumi-1 deployed in May 2025, Yamatsumi-1 deployed in June 2025, and Kushinada-1 deployed in August 2025. Yeah, so that's, you can see. So right now this mission is 6 out of 6. 6 out of 12 total planned launches under Electron, and for this year it's going to and for this year 2025 it's 6 out of 8 planned launches under Electron rockets here. So you can see here, this is what it looks like in this launch. And of course, if you see from my thumbnail of the rocket launches, I'm using this one, I'm using this photo here. This one launched in 15 December 2023. The mission title, of course, is the Moon God Awakens. I'm using the Suguwa-1 here. That's why I intentionally chose this one, because this is beautiful, you know. Basically, how do I say? Even though I know that rocket is basically quite flammy here and there, but sometimes some of the composition actually blends pretty well with the nature and the surroundings. So I can say, why not? I just choose this first. It really describes how it looks like there. And sure, I can use all of this another 4 here, right? I can use another 4 here, but it's not really the best one that represents not only the fiery and exciting nature of the rocketry itself, but also the nature and the sky surrounding it. You can see the nature here and there. You see there's like a ground with the grass. It's pretty dry. Yeah, pretty much you can see like this autumn fall season there. You can see, because a little bit of the how do I say, like brownish color there, and also the sky itself with some clouds there. That's why I intentionally chose this one. This one represents pretty well of the excitement of the rocketry, and also the calm sky, and also the beauty of the nature itself. So that's why I chose this first one. If you see in the thumbnail there, or if you don't want to wait for the thumbnail, you can wait until the end of the stream. You will see the thumbnail itself one last time before I finally close the stream. So yeah, and this is the overview. You don't have to watch it again. A bit generic things, and you can and here you can see here the logo. How do I say, the mission patch? What the meaning of it? Each one of them. You can see here. If you see, there's like 1, 2, 3, 4, 5 stars here. This one represents the 5 stars for previous iQPS missions on Electron. And you can see this is the Electron on the center middle of it. And you can also see there is like a compass and star, that one is representing that one is actually representing Yachihoko as the nation building and navigational god. That's very important. And also this one you see city line and tree basically representing the nation of Japan. You can see here, and the Electron rocket itself. Of course, what else you want to say? And which launches the satellite, of course. Pretty self-explanatory. And also you can see something that looks a little bit UFO-y outline there, because of course this is a little bit of flat design, so it looks like the UFO spacecraft, but I can assure you UFO slash there's another term if I remember correctly. Yeah, how do I say? It's nowadays they also sometimes call this the unknown UAV, something like that, like unmanned aerial vehicle craft there. but I can assure you this is not either of it. This one is how it looks like from the outside if you just outline everything else. So this one is the satellite itself. Yeah, of course, the QPS SAR 14 here. Yeah, I really want to use dimension, use the dash, but I don't know, not. I just don't like. I just don't want to use it for now. Maybe just say here and there. Oh, okay. All right. So looking pretty good. And so this is how it looks like. Okay. From what launches. Okay, and this one is the timeline, aka this launch event sequence here, just for us to actually going back and see what do we actually experience here. You can see the flight itself going up, and then some gravity turn. Yeah, gravity turn are pretty important here, especially the yaw and pitch part there, to ensure that it can be otherwise, instead of it's going to space and then going back to Earth in fiery re-entry manner, it's just going to turn to follow the Earth's curvature there, just to ensure that it can after it goes outside of the atmosphere, it can, instead of the gravity pulling it back to Earth and then re-entry back, there is still some gravity pull there, but it's still not enough to cause it to fall back on the Earth. So that's why it's very important to ensure it can go to the orbit, of course. And here you can see there up until it's fully flatlined there. So I mean, it's technically not fully flatlined. It will follow the Earth's curvature, because as you know, Earth itself it's not I can say with 100% confidence it's not flat. Okay, yeah, despite some how do I say this without really come out too strong, but I don't know. Maybe the best I can describe it is like without because most of them I can say they just lean too much with conspiracy theory. Everything must be conspiracy theory, not everything else. No, it's not. If it's not, it's weird how we can even use some basic things like GPS. That's not something you can easily just say, oh, how about let's use this ground station this ground station to do some triangulation stuff. I mean, even though technically it can be feasible, but there is some problem if you want to go with that route. Do you really want to put every station there, every measurement station or whatever, just for you to triangulate something, right? It doesn't make any sense. It's going to cost a lot of the maintenance, yet let alone even anything else, just for you to just put every ground station, almost every spaceway. I don't know, maybe maybe every 60 kilometers or even 100. But even then, that's not feasible, because I can assure you, if what supposedly this flat earther wants you to believe it's actually true, I don't think I could even use GPS satellite. I can use the GPS technology in the rural. How do I even pronounce this? Because my tongue are pretty short. Okay, so I mean, if that's actually the case, how do I even use GPS technology inside the rural area of Sarawak, or even Borneo, or literally anything everywhere else in the rural area around the world? That doesn't make any sense. That's why the GPS is still there. Sure, it does have that triangulation technology combined there, but at least you don't have to build every of the ground measurement station, or maybe integrated together with the mobile network there, just to detect every movement there. That doesn't make any sense. Or like this, if supposedly this satellite technology doesn't work, I don't think I can even explain how such people in the rural areas, especially if you ever been around the northern part area of Sarawak, you know there's still a lot of some unpaved road. Although most of this although this situation is pretty much, how do I say, it's slowly improved over the time, and also the coverage itself for the mobile slash cell network there, it's not 100% the best, not really good, here and there. But that doesn't but if this supposed weird conspiracy theory is true, I don't think this rural people area can even use Starlink technologies, or even from the Starlink satellites itself, let alone even using the Mesat satellite technology. It doesn't make any sense. Okay, I mean, I know this too is a little bit different thing. Like the Starlink, it's around the low Earth orbit, and it's actually good, fortunately. And the Mesat satellite there, that one is actually around the geostationary Earth orbit there, around 36,000 kilometers of altitude. For Starlink, it's varied. It could be from as low as 272 kilometers of altitude to higher up to 571 kilometers. Like that, can be slightly a little bit higher depending on the solar cycle. If I remember correctly, the solar cycle already peak around, how do I say, already peak around few months ago, if I remember correctly. The peak one is actually around July, if I remember around June, July, August, something like that. So yeah, that's also pretty much dependent on that too, because solar flare can obviously disrupt not only the satellite itself, but sometimes the particle itself, a lot of the particles and the electrons itself pushes around the satellites, can also make it can make sure the satellites re-enters way sooner than later into the atmosphere destructively. So that's also pretty dependent on the set orbit, and also the upkeeping itself using thrusters and whatnot. So yeah, that's that. Okay, and enough of talking. So let's going back on the launch event sequence here, and also the timeline around before the launch itself, around T-2 minutes. The launch auto sequence begins, aka mostly that's where the computer already take over most of the operation itself, and then T minus 2 seconds, all of the 9 Rutherford rocket engines ignite, and then T minus 0 minutes, it lifted off. Okay, and then and also as I have already said in the commentary, okay, around T plus 56 seconds the vehicle goes supersonic, Mach 1. Yeah, although I do have a little bit of mix up with that. Vehicle supersonic, aka already reached Mach 1, breaking the sound barrier, and then around T plus 1 minute and 8 seconds into the flight, yeah, it does reach max Q, which is maximum aerodynamic pressure fully exerted on the launch vehicle itself. And usually around that time, usually if I remember, after it reaches supersonic, or maybe a little bit before the supersonic, maybe Mach 0.7, like that, the rocket engines itself, all of the 9 Rutherford sea level rocket engines there, would be basically tuned down to maximum around 60% throttle down, just to ensure the launch vehicle itself did not experience full brunt of the atmospheric pressure, let alone even the maximum aerodynamic stress there. So usually it will be tuned down until it finally passes max Q. Okay, after it passes max Q, all of the 9 Rutherford rocket engines would be fully throttled up back to 100% shortly after that. And then at T plus 2 minutes and 30 seconds, we did witness the main engine cut off, Miko, on the Electron's first stage rocket engine. All of 9 Rutherford rocket engines, not to be confused with Merlin. Sorry, just a little bit thought if this is SpaceX, yeah, but no risk. After that, it cuts off, and then the stage 1 separates from the stage 2. You see the interstage separation there at T plus 2 minutes and 34 seconds. And then no longer after that, around 2 minutes, T plus 2 minutes and 37 seconds, the Electron's second stage Rutherford vacuum engine ignites. As you can see, it's basically this, as you did see on the launch itself, it's actually basically the same Rutherford sea level rocket engine, okay, but instead of basically clustering the 9 individual Rutherford rocket engines, it's just only take one of it and just optimize it a little bit more for the space environment, aka the near vacuum environment in space. Of course, it actually expands the nozzle bell up until, if I remember correctly, usually this small short, usually up until, let's say, generally around the even the biggest up until the end of the nozzle itself. Usually the sea level will extend up until, if I remember, up until matching the combustion chamber diameter, usually by generally, from my perspective, and also from my a little bit of experience watching it mostly on videos and also on live, and usually it expands the exit nozzle there by, let's say, by how many factors there could be 3, maybe 4, or maybe even 2. Yeah, usually why this optimization is very important is that because you need to know that most when it's in space, because it's almost perfectly near vacuum there. Of course, most of the heat and also the flame particle inside of the rocket engines when it ejects, usually because there's literally almost no atmospheric pressure that literally that it really keeps the shape of the flame itself, it usually would be going out. And most of this going out, this one is not just your typical stuff, okay? You need to remember this particle, this one is super accelerated, going out from the slowest inside the combustion chamber, and then later in the throat nozzle there, basically applying the Bernoulli slash the steam engine design there, reaches on the throat of the nozzle itself. It's going around Mach 1, aka the speed of sound, and then when it exits, usually it would goes beyond that Mach 1. After that, it's mostly it's going to push out probably around supersonic or maybe even hypersonic nozzle speed there. So that's why it's very important they just put the nozzle bell extender there, so they can maximize all of that thrust left from the push of the flame itself going out from the combustion chamber and also the engine itself. So that's why it's very important. Okay, and after that, around T plus 3 minutes and 32 seconds, the frame separation did occurred on the flight, and then as we also saw, around T plus 6 minutes and 29 seconds, the battery hot swap occurred, basically switching from these two already almost depleted battery. It changes to another into another pair set of the unused slash unutilized battery there, because you need to remember all of these rocket engines you see in this flight essentially were powered by the battery. Yeah, battery and the motor, if I remember correctly, the small little motor there, instead of, let's say, using typical rocket engines like using turbo pumps, maybe exhaust maybe like the whatever exhaust pump, whatever is it, instead it's replaced by the motor itself, by the motor shaft, if I remember correctly, connected into the flight computer and also the battery itself. So that's why the battery hot swap procedure is very important, because it's still, because in terms of how do I say. Alright, looks like by now it's already T plus 50 sorry, is it? Okay, T plus 40 minutes and alright, T plus 41 minutes, we shall see the kick stage QE or maybe hyper QE engine ignite. But for now, let's go back. Okay, that's why the battery hot swap is pretty important there. And after that, around T plus 9 minutes and 4 seconds, we did witness the second engine cut off SICO on stage 2. And after that, and then no longer after that, around T plus 9 minutes and 9 seconds, the stage 2 separates from the kick stage, and that's basically became a ballistic coasting flight for tens of minutes up until now, which we'll see around T plus 46 minutes and 34 seconds, the kick stage QE or maybe hyper QE engine will ignite, and then followed almost 3 minutes later, or specifically around 1 minute and or specifically around 2 minutes and 54 seconds into the kick stage QE ignition. Alright, what's okay? It's good. What's happening? Never mind. And after that, around T plus 49 minutes and 25 seconds, the kick stage QE engine will be cut off, and then plus minus around 15 minutes and 60 16 seconds, could be a little bit longer, or maybe it would be or maybe slightly lower than that. We shall see the payload deployment for the QPSR-14 satellites, aka Yachihoko-1 satellites then. So that's you need to know. Okay, and I need to see what's happening. Is it good? I think it's a little bit. Yep. Okay, looks like we have a little bit of weird hiccup here and there, but fortunately it's fine. Yeah, okay, fortunately. Oh, thank goodness. Because I'm actually feared for something much worse, but fortunately, because this is early morning right now in Sarawak right now, so around around 4:36 a.m. here right now, so the mobile network congestion here is not really that worst, so it's pretty relatively fine experience here for this early morning. Okay, alright, should be good. Alright, a little bit of troubleshooting doesn't hurt you, huh? Okay, so here you can see this is the Electron launch vehicle itself. When you actually dissect it one by one, this is how it looks like on the exploded view of the Electron launch vehicle itself, the rocket itself. Yeah, you can see here, but I can give you a little bit of specs here of the overall rockets here. It actually has 18 meters length long there, with the diameter maximum of 1.2 meters there, and it does have two stages plus kick stage if it needed, if it does need kick stage, but if it doesn't, two stage alone can still be good. And usually the launch vehicle mass itself at liftoff is 13,000 kilograms, aka 13 metric tons here. And the material slash structure here, it uses carbon fiber composite slash monocoque how do I even pronounce it properly? Monocoque or MONOCOQUE. Yeah, I don't know how to properly pronounce this without even destroying the meaning. Okay, and getting ready for the QE kick stage engine ignition. Okay, and the propellant itself is of course Kerolox, liquid oxygen as the oxidizer, and the super refined kerosene, the RP1 rocket propellant 1 as the fuel itself. And usually the payload, by nominal payload, usually it can go it can actually carry up to 320 kilograms, aka 440 pounds to 500 kilometers of low Earth orbit. Okay, by now it should ready. Okay, T plus 46 and 34 seconds. The kick stage QE engine should have already ignited by now. If not QE, maybe hyper QE. Yeah, because there's two versions of it. Okay. And the fairing diameter, of course, the same as the rocket itself, the 1.2 meters. The height of the fairing is 2.5 meters or 2.5 meters there. And usually by fairing separation system, it uses pneumatic unlocking and also springs there. So yeah, gone are most of the day where separation are mostly by pyrotechnics or explosive bolt manner there, you know. But mostly nowadays they don't use it because it can be pretty damaging, not only to the satellites but also for the can be also damaging to the rockets itself. And also thanks to the advancement in aerospace, especially the materials material science there. So that's why, and also some engineering level there, like mechanical engineering, anything that's involved with this separation system there. Nowadays, most of the separation system on the modern rocket usually is using pneumatic unlocking and also spring system rather than pyrotechnic, explosive and pyrotechnic and explosive both there. So that's that. Okay, so looks like it's already
Stunning liftoff
alright.
at 8:51 New
So
Zealand
here we
time
go.
from Launch Complex 1.
There.
Today's mission was, as we like to say, nominal.
Yeah,
We ticked
nominal.
off all the usual milestones like
And
Max
also
2,
here I can
Eco, Stage 2
tell a
burn,
little
and
bit about
Seco
the
to set
stage
us
2.
into a
Yeah,
transfer
this is
orbit
the
where
stage 2
Electron
of
separated the kick
second
stage
stage
with the
rocket engine
QPS
there.
SAR
You
14
can see
satellite ahead
it's
of
like
payload
the super
deployment.
optimized
That's right,
version of
and
the
since the kick stage's release from Electron, it has
of the
completed
first
its first
stage
half pass of
Rutherford
Earth
rocket
and
engine.
let its
This one's
Curie
the
engine to
vacuum.
position
You can
itself
see
in a
it's
circular
basically that's why I
orbit.
said
We're
it
now waiting for
expanded by
confirmation
the
that the
factor of
engine has shut
3,
off,
4,
which will
sometimes even
mean we
5,
are just moments
depending
away from
on
payload
the
deployment for the Nation Guard
rocket
satellite like
uh,
Yachihoko-1. Let's listen
on
into
the rocket
Mission
engine
Control to hear
equation,
their
of course.
final call out
That
on
one I'm
payload
still
deployment.
currently learning, but
Nominal final orbit achieved.
okay, nominal final orbit achieved. Around, yeah, okay, ready.
There we have Curie cut off, waiting now for payload deployment.
Should cut off by T plus 49 minutes and 25 seconds. Okay, get ready. That's here. The call out. Okay, this is the animation there. Okay, didn't call out outright, but by now it should have already cut off at T plus 49 minutes and 25 seconds. Okay, good. So you can see this one is the optimized version in vacuum derived from the first stage, of course, of the Rutherford sea level engine.
QPS SAR 14 confirmed.
Okay, looks like already confirmed pretty early. Wow.
Congratulations to the team.
You can see it's already done.
That's payload deployment confirmed.
Wow.
Mission success for Electron.
Looks like the mission
Nation God has
successful.
officially joined its fellow iQPS gods and goddesses.
Yeah, so congratulations to Rocket Lab for successfully launching this one, and congratulations to iQPS for the successful for the satellite finally successfully deployed into the circular sun-synchronous orbit 575 kilometers with the orbital inclination of 42 degrees there. Pretty good. Okay, so oh no, why
And while it's nearing the end of the year,
okay,
Electron's schedule is not slowing down. We have
Oh,
plenty more launches on the books before year's end,
Oh,
so be sure to keep an
almost.
eye out on our socials for
We
more
almost
details
walked it.
on those soon. And before we close out, let's take one
oh no, let's go. See what's wrong here. Shouldn't be like that. Alright.
last look at today's stunning liftoff. And until next time, this is Rocket Lab Mission Control signing off.
Oh no. Oh no. Okay, so this is the launch replay of the launch itself, just few moments ago. And yeah, that's all everyone. So thank you for watching, they said. And also for new viewers or maybe existing viewers, hello and welcome. And yeah, we've already finished it right now. But what I'm going to do is I'm going to also finish up what I want to say here. Alright, so let's go with this one. Okay, so here, of course, it does have a little bit of some thrust here. Thrust level, it says. Oh no, why does it even have to use imperial system here? Oh no, I really need to translate this one. Oh man, how do I even say? Maybe I can try. Let me use my phone here. so I can translate all of that. Okay, because it's on pound force there, so I need to change it into kilograms per force at least. Okay. Oh no, I really don't like this. I mean, at least keep it consistent, but you cannot. Huh. Okay. So on the thrust, on the Rutherford vacuum engine thrust level is at maximum it can deliver around 2000. Okay, let me read here. 2630.84 kilograms of force, aka in the imperial in the imperial terms, it would be imperial measurement terms, it will be 5000 in 800 pounds force in vacuum. And of course it does have the specific impulse of 343 seconds, should be translated roughly around 3.337 something like that kilometers per second of the exhaust velocity when it actually finally exits from the rocket nozzle there, you know. So that's that. And also this interstage, you can see the separation system also the same, just that it uses pneumatic pusher rather than unlocking alone, because remember it doesn't have any springs like in the frame separation here system here, so it uses the pneumatic pusher. And of course the reason why it's just referred to my earlier explanation there, but just long story short, because of the material science advances, some of the mechanical engineering breakthrough and here and whatnot, whatever whatever applicable is here. And also second of all is that because pyrotechnic and also explosive bolt separation by default is pretty destructive even on the small charges, that can cause some damages into, if not the rockets itself, it could be to the payload itself, to the satellites, or maybe even the whole, maybe both of them. So that's why it's very important. And of course the stage 1 almost similar to the vacuum engine, because vacuum engine is the derivative from the first stage rocket engine there. And on the first stage it does have the 9 Rutherford sea level engines there with the thrust level per engine there. Okay, let me convert because it's painful trying using imperial measurement system alone. So I'm also going to convert into the metric measurement system. So in kilograms force, it will be around 2440.12 kilograms force, aka also in the imperial measurement system it will be 5600 pounds force sea level per rocket engines itself. Of course you can see the arrangement itself is basically like, how do we call this, the Falcon 9-esque SpaceX rocket engines, how do I say, lining, something like that. You can say it's pretty neat and also pretty efficient for the space and side using this configuration. That's why you see most of the aerospace company, aka the rocket companies itself, they uses this because it's pretty efficient on the volume and also spacing, of course. And also aesthetically it's also looking pretty beautiful if you see on the bottom side of it, so that's why. And for the specific impulse, of course, because we are talking about the atmospheric pressure and whatnot surrounding it while in the was still back on Earth, of course it's going to be 311 seconds, aka should be translated around 3.02, maybe 3 kilometers per second of the exhaust velocity when exiting the rocket nose itself. So that's that. And looks like we are done. We are complete there. Okay, maybe I can change a little bit to full screen just in case. And that's it, everyone. Thank you so much for watching this live stream. So yeah, I really want to have some sleep, have some nap here, because of course I need to prepare for the stream of if you actually notice, the I've already put out there would be the Atlas 551 rocket configuration there. Basically full stack. If I remember, around 5 SRB, 3 SRB solid rocket booster on this on the left or maybe right side, and another pair sets to basically two SRB on the opposite side there. That's also going to be very interesting, and hopefully I can stream that, because I don't know, a little bit some of it can a little bit confusing, and also a little bit clashing with my timetable, but I'll do my best. Hopefully I can catch a little bit. Hopefully most of my courses will be finished before the bus transportation time, so I can just go back to where I'm living right now, and then I'll go and stream for that one. Because you want to know something, it's actually pretty notable for me. And you want to know something, since I've already witnessed rocket launches and also getting interested in rocketry around, if I remember, up almost around 10 years ago, if I remember, up until a little bit slight extend around 13 years ago. That's where my rocketry journeys begin. My interest on that rocketry stuff. So yeah, it's pretty emotional actually to witness, because that one, especially where I hope I can stream that one. In that one in question, it's going to be a Viasat 3 Flight 2 satellite mission, right? It doesn't sound like a big deal anything, right? It's like nothing bigger. But you need to remember, the Atlas rocket era as a whole already almost closing in, you know. And that mission, it's going to be the last, as far as I know, it's going to be the last mission that will go not only to the heading to the geostationary, or at least going to the geosynchronous transfer orbit, but also this is going to be the final customer commercial customer, and also mission outside of the Boeing Starliner and also the Amazon's Project Kuiper satellite. So of course it's pretty sad. The era is pretty closing in, you know. I mean, I do actually wish back in the day, life as a whole didn't suck that much. And yeah, I do really wish I was a little bit of young adult at that time, because otherwise I could just go and stream that launches, and maybe, I don't know, maybe I can be a little bit of pioneer in this stage back where live stream is not very common. And also, you know, and also because as you know, Clear Usui didn't exactly come into the space flight VTuber scene up into the essentially the VTuber in general, and also the space flight scene up until around July 2020, if I remember correctly, or August 2020. Yeah. And if I remember, one of the first launches that she actually covered back then is the Delta 4 Heavy. That one is for the classified enroll. I don't remember. Maybe enroll 56, enroll something else. Yeah, it's pretty long. Thing like 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 in terms of era, it's like a little bit bygone era by now, because like what I mentioned there, even Delta 4 Heavy no longer operational, you know. I do really wish I can cover that stuff, but yeah, unfortunately life really has something else for me. Yeah, it does have some other special planning for me. I mean, not really exactly special planning, more like life really doesn't treat me well around that time. So basically, that's why I'm kinda laggard here. Not because I don't want to do it at first, but life really doesn't treat me very well back then. So yeah, it's also pretty bygone era, you know. And also it's going to be the last time the Atlas V rocket as a whole will be going beyond the low Earth orbit. And after that, we are going just to see it's going headed to the low Earth orbit, mostly for the Amazon's Project Kuiper satellite, and also and also for the Boeing Starliner mission, especially the crewed, maybe some crewed mission to the International Space Station. But by then we don't even know what if Boeing could even properly finish their job with their Atlas V rocket as a whole before ISS itself, the International Space Station, scheduled for the orbit the orbit around 2030, if I remember correctly. So yeah, that's also a bygone era. By then it's going to be almost 30 years since human since there's continuous human presence in space, you know. And by then maybe I'm maybe by the time the deorbitation happens for the International Space Station, but maybe by then I've already busy working something else, you know. I mean, busy working like in literal terms of not necessarily about streaming rocket stuff. Maybe by that time I'm too busy with my job, but I don't know. Let's see what's the future will bring to me. If I'm lucky, maybe I'll be in time to actually stream that. Maybe if I'm even luckier, maybe life, maybe universe, maybe even God will give me chance to actually try go and stream there, you know, because I don't want to miss it. That one is one of the best. I can say that especially if you see lately, especially where we are right now with the space program, we are essentially already around the golden age of space exploration, if you even seen it. I mean, even since lately up until, if I remember, I can actually pinpoint as early as mid 2010s, if I remember correctly, as early as 2014, 15 and 13, even though there's some upset, you know, with some DV supply mission to the ISS basically gone bulk around, especially in 2015, you know. If you know about a little bit of history there, the Cygnus spacecraft that should be scheduled to go to the International Space Station around 2014 or 2015, literally called as the SS Dick or Decade Slayton, unfortunately fell on the slide because the Antares rocket engine series, if I remember, the Antares 100 series, if I remember at that time, Antares 130s, if I remember, 130 plus, that it literally fails. You know why? The first stage, if I remember, the first stage turbo pump, especially the combustion chamber, literally fell because you need to remember that back when actually the orbital science debut with their back then they actually called themselves as the orbital science, and then after that orbital etiquette, and then after that being bought by the Northrop Grumman as the Northrop Grumman Innovation Systems, if I remember correctly. back then, when they actually procured that rocket engines with the two rocket engines itself, they are actually using the NK-33 rocket engines, aka, how do we call this? I call this as the Soviet moonshot rocket engine there. Yeah, for their felt N1 moon rockets, rocket engine for the Soviet back in the day, in the 60s. You know, a little bit of stuff there. It felt the first stage rocket engine. It felt, and a boom! It's just hitting the ground. It's literally shaking. And I remember correctly. I remember back then, if you're a little bit of veteran on space flight, especially the viewing related, you might know this spacevid.tv, right? That one of the, how do I say, channel that actually influenced, not only influenced but also I actually also thank to that channel for literally putting me back in, not only putting me back but actually introduced me to rocketry as a whole, because I remember the launch catalog they actually produced, but nowadays the channel itself mostly already unlisted some of the video. If I remember, there are also some videos that I can say it used to be very available, albeit unlisted, also practically already gone right now. Especially one of the important thing is, if I remember, is the Delta 3 rockets, if I remember correctly, about the playlist itself. If I remember, that channel actually almost have complete launch video of it, but unfortunately it's just gone like that. Poof, SpaceVids.tv is basically just gone from that scene. I don't know what's happening. I don't even have any insights regarding what happened to that channel. Yeah, pretty unfortunately, but I guess everything's changed. Everyone's changing, growing up, you know, and you know, that's one of the key event I remember back when I actually got very interested with the space flight and also rocketry in general. Yeah, one of the crazier time. And also I remember one of the time with the Falcon 9 rocket, especially the CRS-7 mission. Yeah, it actually also felt just few tenths of seconds before the first stage, Miko, the main engine cut off. You know why it actually failed? If I remember, it failed because of the COPV, the composite overhead pressure, pressure. How do I say? Or what the vessel itself actually failed. Specifically, the helium tank actually failed. So that's the reason why CRS-7 failed. Just 2.5 plus minutes into the flight, the CRS-7 it failed too. And then I remember around sometimes also 2016, 2017. I remembered SpaceX actually planned to launch the Amos 3, Amos 4 satellite. They basically mostly built it for Facebook, if I remember correctly back then. Nowadays they call themselves as Meta. You know, it felt one on the preparation, and that one is actually also if I remember, also for the similar reason to the CRS-7 failure, COPV failure, on the COPV failure. But if I remember, it's not related to the helium. If I remember, it's mostly on the second stage, a liquid oxygen tank. It failed. It's basically leaches together with the helium, if I remember, and then these two didn't go pretty well, and kaboom! It's just exploded on the launch pad before it even lifted off. So yeah, that's why I said the bygone era. I'll say we are almost approaching there. I mean, even myself talking right now, it's like It's like we are talking about the dinosaur era at this point. We are basically straight up talking about space archaeology at this point. Well, but yeah, I guess that's it. I don't want to talk too much because I need to get myself prepared, and also because I want to take a nap and sleep a little bit, you know. So that's that. And for the Viasat 3 flight number 2 mission that will be launched on 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 board onboarding the Atlas 551 rocket itself. That one, it's pretty dependent. If I can take a good bus schedule time, I'm able to be back here back in my room, of course. Maybe I'll be able to stream a little bit slightly longer before that. But otherwise, if other cases happen, maybe I'll suddenly have to go to stream because yeah, what else you can do? I'm student at the end of the day, you know. I mean, specifically, maybe some of you might ask. I need to repeat again. I'm not an aerospace student. I'm just a computer science student. But my interest is very deep here. So deep, I can say it's harder to get out from the rabbit hole. So that's that. Thank you so much for watching, and also thank you for the viewers that are also watching. I saw around 5, 4, 3 concurrent viewers. You guys actually rock, you know. I mean, I'm not really expecting you guys to actually stay this long, but I don't know, maybe because you guys already watch a lot of VTubers streaming, chill streaming, or maybe you might already watch a lot of clear Usur stream that you can stay a bit longer. I mean, I really appreciate it. You guys have the best attention span here. So yeah, thank you so much for watching. Take care, and I'm going to rest a little bit. Goodbye, everybody. See you when I can stream that. Hopefully not in rushing state. Okay, so that's it. Bye bye, everyone. Take care. And yes, there's literally nothing else you want to see here. I mean, what else? Okay, straightforward. Okay, bye bye. Take care. Have a rest. Yeah, and also please take care of your own sanity. Okay. Alright, bye bye.